This question is actually on organic chemistry, and it's going to help in the synthesis of the compounds. But one good thing with this question is that before you answer any question, try to make sure that you confirm the organic compound. That's the major thing. And of course, you know the kind of reaction you undergo. Now, this question is saying complete the following reaction scheme which starts with ethanol. This is ethanol. This is the functional group CHO, something like this. So this is what we actually have there. So now, looking at the reaction, this is going to undergo. This one's reacting with Tollin's reagents now. Of course, in Tollin's reagent, we understand that the silver ion is reduced to silver mirror. So over here, oxygen number is +1. Over here is now 0. That means it has reduced this silver ion to silver metal. So that's why we have silver mirror shown, silver mirror precipitate shown as an observation. So in this case now, automatically this is undergoing oxidation, while the silver is undergoing reduction, this is undergoing oxidation. And it's going to oxidize from carboxylic acid. Whenever we have alkanal undergoing reaction with Tollin's reagent, which is oxidation, it will give you carboxylic acid. Other oxidizing agents, we have the acidified KMNO4. We have the acidified K2CR2O7. We have the Ferlin solution. So these are oxidizing agents. So our answer for this place, in this place is CH3COOH. And don't forget the instruction says write the structural formula. So that's why we are keeping it in this format. So the one good thing you should do is to follow the instruction given to you. So this is just the reaction. Name of the reaction in this case with Tollin's reagent is called oxidation reagent. Like I said earlier, concentrate on identifying your functional group. Then you need to know what to write next. Now, this CH2CH2 is also undergoing reduction. The reducing agent we always use is lithium aluminate, H4. We have sodium borate, H4. We also have a case of hydrogen with platinum or palladium or nickel. Also, we have sodium plus ethanol. So now all these, they are reducing agents. So whenever you are reducing your alkanal, the ethanol here, don't forget alkanal is always reduced to primary alcohol. Always. Alkanal always reduced to primary alcohol. Then alkanone is reduced to secondary alcohol. In other way around, the reverse is different. In terms of reverse, we have the primary alcohol. If it undergoes oxidation, it's going to give you alkanal. Secondary alcohol, if it undergoes oxidation, it will give you alkanone. So don't forget that. So that always happens. So that's what we have here. So using reduction, obviously it's going to give us CH3, CH2OH, because reduction is addition of hydrogen. If you write this equation out, so we have in CH3, CHO plus H, that's always 2H, we now give you CH3, where our O now will receive hydrogen and also so we're going to be having CH3 here, H, these are the two H we are talking about here. Then we have now the OH. So that's how we have it in that format. So that's how I get that particular answer. So now let's deal with other things. We have found D, we have found E. Now let us quickly look at how we can find others. Let's look at how to find the HCl. Now HCl is hydrogen cyanide. And don't forget, sometimes students confuse you with KCN. When you are dealing with halogen such as CH3, CH2Br, then in this case, we do have to react this with ethanolic KCN, where we have ethanol. But when you talk about alkanol, that's aldehyde, alkanal, that's aldehyde, and alkanone, that's ketone. These ones, they react with HCN, and the condition, of course, NaCN. So there are two different things in terms of reaction. So let's have that in mind. So in reacting with, sorry, I'm rubbing them off on time because that's my writing space. You can pause and do what you have to do. Please just what is here. So in this case now, we have this. I will also tell you the mechanism or show you the mechanism of reaction. We have CH3. CH3. So over here we have CO, then we have H. Now the mechanism of reaction is this. This oxygen is electron withdrawing, so either negative, it becomes negative, while the carbon here becomes positive. Your Cn will be coming from a suitable angle, which you can set in your exam anytime. Don't forget the lone pair here and a minus. So it's going to attack the carbon, not the bond, the carbon, because the carbon is going to be electron deficient. So you'll be having an intermediate of this format. So here you will now be having O minus with a lone pair. Then here we have Cn. Now you have your hydrogen. So this hydrogen is it. This is your Cn, this is your O nitrogen. So this is going to react another molecule of HCN. So let me say HCN. So this Cn electronegative, so it's going to pull this to become minus, while it's going to become positive. So your oxygen that has a lone pair is going to attack the hydrogen now. Attack the hydrogen. So as I attack the hydrogen, it's now going to have CH3. Final answer will give you COH. You have your Cn and you have your H. So this is what we call propanitride. Propanitride. So 2-hydroxyl because 1, 2, 3 here. 2-hydroxyl propanitride. So our answer here is CH3, CH into bracket OH, then Cn.